Good morning. I am Jay Cottrell, the Global Marketing Communications Manager here with Laser Technology, and I would like to welcome everyone to joining us for the Seiler Geospatial and joint webinar with us, documenting pole audit inspection and measurements best practices. This morning, you will be able to interact with us through the Q&A panel, which is if you go to the upper right-hand corner of your screen, you should see two communication bubbles. If you click on that, you will open up the Q&A panel. Feel free to ask questions throughout this. We want this set up as a conversation, so we'll definitely be breaking in and answering those questions as they come up and as they apply to what we're talking about. So with that, I'm going to hand it over to Derrick, and we'll get started.
Hey, thanks a lot, Jay. I appreciate that. So welcome to everybody to the webinar today, documenting pole audit inspection and measurements best practice. So we've got today a panel of experts from Laser Tech and Seiler. My name is Derrick Reish. I'm the Senior Product Manager here with Laser Technology, focused on the Professional Measurement Division. And I've been with Laser Tech for the last 21 years, coming up on 22 here shortly. So also with me is another colleague of mine, Steve Colburn.
Good morning, everybody. I've been with the company about 28 years now. I've been involved with all the products and solutions we provide, sales and marketing activities, service, a little bit of test engineering. So very familiar with a lot of these applications. Happy to be here.
Thanks, Steve. And we got a couple guys from Seiler. So why don't you guys introduce yourselves, please?
Hi guys, my name's Joe Madej. I am mapping technical support for Seiler Instrument. I've worked for Seiler for about 6 years now, and I work out of our St. Louis office. And prior to my job at Seiler, I did about 3 years of pole audits. So this is kind of in my wheelhouse.
Perfect. Thanks.
And this is Jay Riester, Senior Mapping Support Technician with Seiler Instrument. Been with Seiler for about 13 years. Certified trainer, Trimble trainer, assisting our customers with Trimble mapping workflows, Azure mapping workflows, and of course LTI products. I too had some experience in the field, but not as long as Joe doing pole audits.
All right. Well, hey guys, I really appreciate you being here today. Just kind of talk about this application. Just a quick background. If one of you guys want to give me a quick background about Seiler, that'd be great.
Sure. So Seiler, we are a family-run company. This year we're celebrating 75 years. Seiler's headquarters is located in St. Louis. This picture you see here is our geospatial team, which does survey, mapping, and construction on the Trimble side of it. So we have quite a few people that work on that side of the team in different states to help and assist your needs. So we're actually located in quite a few states. So each little dot you see on the map there is where we have an office. And we've recently acquired the state of Michigan, formerly Michigan Survey Supply, is now Seiler Instrument. So myself, I'm based out of the Missouri office, and I normally travel to Kansas City and Indianapolis, as where Jay is in the north, and then we have another tech support person that's in the Detroit area for us up there too.
Great, thanks a lot, Joe. Yeah, in Laser Tech, we've been a partner of you guys. I think I've been with the company over 21 years, and we've been partners with you guys for that long, if not longer. You guys support Laser Tech really well out there in the field. Here at Laser Tech, we design, manufacture, and distribute laser rangefinders for all different type of industries. And so we're based out of the suburb here of Denver, Colorado. So we've got our service center here, but we also have service centers across the world to help out with our products. And with all that, we've been celebrating over about 34 years in business, and over all those years, we've got, we've been designing and laser rangefinders. So we've got a lot of patents on all of our equipment and devices here and solutions. So Seiler is one of our premier authorized dealers here in the United States, but we have dealers across the world also, just to let you know that, where we work from. And being a manufacturing company, we are ISO 9001 certified. Everything we do here at Laser Tech. So the agenda today, just we're going to keep this right about 40 minutes or so, talking about, again, these topics here: joint use, pole audit overview, just different measurement values and routines that are needed. You've got a couple experts here that have been in the field, so that's really good to listen to what they've seen and how they've used different equipment, how they document some things, and then also just kind of a quick recap. So I'm just going to go ahead and dive into this, guys. Again, kind of more of a dialogue today is just kind of your past experience. For the people that don't know that, what is joint use or what is pole audit?
What pole audits would be is there's a whole slew of different scenarios you can have when you do a pole audit. The majority of what I worked on would be we were counting the attachments that were on the pole or who potentially owned that pole in terms of rent. So power companies might go out and they can set it up so the NESC will come out and say, we would like you to do an audit every so once in a while, but it's really under the discretion of the power company or who owns the pole. How many years are they actually going to go out there and do a pole audit for ours? Because the one that I worked on, my last job that I worked on, it took us 2.5 years to do about 250,000 poles. So it definitely does take a while, especially when you're needing to get hands up, but they'll do it for rent purposes. Who's attached to the pole? Is the pole even good? There's hammer tests that they do to make sure that the pole is still good. And then there's even pole loading to make sure that they can actually attach any type of new attachments to the pole too.
Right. Yeah, I was going to mention that typically we think of pole audits for hanging communication wires, putting additional services on the pole, but the owners themselves often do it for engineering purposes to see if the pole's still viable and structurally sound and that kind of thing. Yeah.
Well, yeah, thanks, guys. And so, yeah, it kind of leads into the, like the why, who, when, and all that kind of stuff. We touched base a little bit about that, but can you expand a little bit further? You mentioned some regulations and inspections and some other companies that do that. Are they private companies? Are they utility companies? What do you guys see out there in the field?
So Jay Riester and we actually worked for a private company that's specified in doing these type of pole audits, and they are hired out by companies, so then that way they don't have to do that undertaking and create it. So they'll go out and bid for that job to do a pole audit. And the one of the jobs that I actually worked on, we wanted to see what type of attachments were at it, and there was actually a lawsuit involved in this audit that I was working on. And one company was suing another company, and they essentially said, let's do this audit to determine who really is at fault in determining how many attachments they had on the pole. And then there's other ones where you have small utilities to see who owns the pole, because sometimes it's a power company that owns the pole, or sometimes it's a telephone company that owns the pole. And then also to see what type of pole there is, because if I recall correctly, there were 3 type of wood poles that we had, and then one of them is actually a cancerous causing pole that they treated with. So it's important to figure out what poles those are too.
Right, and it can be anybody along the chain then, and it's an audit, so oftentimes one entity doesn't trust the other's audit, so you could have, if there's a certain work order that needs to be done, there may be several audits going on those same poles at the same time, private contractors or people within the agencies themselves. Yeah. How about the regularity, Joe? It's kind of on an as-needed basis, or maybe there's some regular maintenance on the poles when they go out and check them for engineering, but it's really driven by when somebody wants to do something on a pole, right, and hang something there.
Yeah, so a lot of times now what we're seeing is we're seeing fiber going out, and fiber build outs are being huge right now, and it's just not in these in the big cities like in St. Louis where I'm at. You're seeing these companies come out of nowhere that are doing these fiber build outs that are taking fiber to rural communities, and that's a huge business right now. And determining, can those poles, can they even attach to those poles and build out the fiber? And in my most of the time, the audits, when it was either done every 5 years, sometimes they'll do it 12 years. It really is determined by who owns the poles, how often they want to do that audit.
Yeah.
Yeah, not only that, I mean, they're looking also for some unauthorized or illegal attachments, right? I mean, people are just saying they're taking them out there to different areas. They can go, well, I'll just put up some lines right here. Nobody's going to even know, right?
Exactly. And then, also, are they in violation in the segments? I know we'll talk about that coming up, but we can talk about the segment violations in the next area too.
Right. No, yeah, and I think that the big thing is to get accurate information while you're out there. So that's, and also for safety factors that we're going to talk about. So that's going to lead us into our first poll question. If we're going to see if this works, we've got a QR code here. If you guys want to, if whoever's online, if you grab your camera, your phone camera, everything like that, maybe take a picture of the QR code and just, are you currently performing audits? We just kind of gauging our audience here to see what we have if you actually do these type of this application. So I'll give it a quick second and see if I'm able to jump over and take a look at the survey results again. So just use your camera from your phone, and we'll see if we got any results here. Let's see if I got this. Go here. Oh, maybe refresh.
You need to go to the LTI 1 poll question.
Go there, analyze. All right. Well, we got a question. We got somebody that came in on here, so thanks a lot for giving us some information on it. So might learn, not performing audits, but learn how this application works. So you can still do some of these. You're still able to get in there and answer some questions here. We've got another question coming up, so for the audience to get some feedback. So I do appreciate the time of everybody doing that. So kind of moving forward, you guys talked about all the needs and violations, and Joe, you talked about like what different values are needed for this. What type of measurements are being taken out there?
Yeah, so in this slide, it's a very good slide to determine. There's 3 segments to the poll, and power always has the right at the very top of it, of those lines, and then there's the neutral space, which there has to be a clearance between certain, like, is it the bottom of the transformer? Like, there's an NESC violation that they need to be 40 inches away from that and give the power company a clearance into if they need to do something to that transformer. Then once they're away from those clearances, that's where those communication lines can come in, and you'll see cable, you'll see phone. Most of the time, what you're seeing on there now is internet, and they're just trying to improve the broadband of fiber speeds on there. And usually that communication space is in the middle half of the line, and then the lower half, there's nothing usually attached to it because they don't want anybody messing with the line. But when I was out there doing my job, we were determining how many attachments were on the pole, and then also are they at a certain distance away from the power line and giving them their neutral space. And it's really a game of inches, because it can be anywhere from 40 inches all the way down to 12 inches being away from those lines.
Yeah, those power clearances are usually 40 inches, communications usually 12 or something, right?
Right.
Yeah.
And also, like you talked about a little bit of some span measurements that might needed.
Yeah, so there's also span values that you can have as well, and that's making sure that it could be power, it could also be the telecommunications that are going across the road. Is there enough clearance going across the road that they're not prohibiting traffic, or they are not, is it comfortable enough that somebody will be able to walk down the sidewalk and not reach up and touch one of those communication or we don't want anybody touching a power line either.
Right, oh yeah, kind of like this right here, this diagram here, talking about the different clearances that are needed, not just separation, not spans, but all these different values are needed to be need to be captured or measured for different audits.
Right, and not just roadways, like Joe said, driveways, bike paths, you know, and sidewalks, anything like that, anything where people or objects are going to be traveling under, right?
So what are they, you know, Joe, Steve, you guys are in the field and you're seeing what people are using to take these or measure these values. What typical equipment that you guys seen out there?
So when we were out there doing that, we were eyeballing our measurements. But I know some people that were carrying a Hastings rod, a Hastings stick, and that's what you see in the photo right there. There's a gentleman with a stick that's non-conductive, and you sit there and measure it, and that's real cumbersome to go out there and carry around. Especially using a wheel as well. You already potentially have. You know, I was talking with Jay earlier, and when he did this, he was carrying a Trimble Geo, he was carrying a camera, he was carrying a laser, he was carrying a competitor's unit, and you know, he had all that to carry, and then he had tags that he had to carry as well. So we want to try to minimize as much equipment that you need to carry out there, because you know, we want to make sure your guys are safe, and it's a very solitary job, and you could be out in the middle of nowhere and carrying all this equipment and get hurt and be stuck somewhere. So let's, you know, minimize the equipment that you have that you need to carry out there with you in the field.
And yeah, you mentioned the safety. This doesn't look like a very safe situation holding this rod up here. But not only that, it's personnel. Like, how's that guy going to know where that rod is touching 30 feet up in the air? He's got to have a spotter back behind there to see when he's got the right height, and then probably also recording the data too. Pretty tough to record the data while you're, you know, wrestling the stick there. So.
Yeah, that kind of leads into some of those safety factors you guys are talking about, or field experiences. And I think one of the biggest things is safety. You know, your guys, you've got workers walking up to each line, or, you know, need to take the wheel and walk around between each pole. Like the kind of photo to the left here is just the low clearance that Joe, you were talking about. You know, like if it's not, you don't have the right clearance, there's vehicles that aren't paying attention. They're just running down the highway and just out one of those lines.
Yeah, and actually the photo that you see on the right was actually taken by me. That was a photo that I came across, and this pole was down, was knocked over by a car, created a fire, and created a hazard. So, you know, not only are we going out there and we're doing pole inventories, but, you know, if we saw this, you know, or we see a down line somewhere, we're essentially quit doing our pole inventory, and then we're on wire watch until the power company can come out and verify that's there. So they also help the power company out, because they're not going out and touching these poles. They're trying to make sure that their product is running and correct. And these pole inventories, you know, we're making sure that there's no harm into what a customer can come into, and you know, somebody walking down the road, we don't need them to touch one of those power lines, because it would be bad news for all parties involved.
All right.
Yeah, exactly. So, and that's going to lead us into just different ways of using laser technology equipment. We're going to talk about different laser rangefinders here. What are laser rangefinders and what they're capable of? We manufacture, design laser rangefinders that can measure distances to all different types of objects with a clear line of sight. So you've got that laser sensor, and there's no need to have a reflector. So talking about some of the things, standing on a safe area on the sidewalk and taking the measurements, those different measurement values, you can do that with a laser and sight right through that scope and know exactly what you're measuring to. On board, we have also a tilt sensor. This tilt sensor measures our angle values. So again, we get plus or minus 90 degrees. And on some other different laser models, we incorporate a compass sensor. So now we're able to measure the azimuth value. So you get your 3D values with that. And so the compass measures magnetic north. gives us our azimuth value at that point. There's certain times where you might be, like around a lot of construction zones, taking these measurements, and the compass might be interfered by magnetic interferences. And we have some devices that we've got where we put in these angle sensors, and now we can do these horizontal angles also. So you're still able to get these 3D measurement values we're going to talk about here shortly with all different types of models that we have. This is what it looks like with a couple different diagrams of what I'm talking about being measured. Again, our sensors measures, the laser sensor measures that slope distance or line of sight distance also is another name for it. But you can see that on the left side, and the tilt measures the inclination, or that degree of inclination where the instrument's tilted at. So you see that we measure that slope distance and inclination value, and on board automatically, with the one press of the fire button, again, those measure, and then we calculate that vertical distance and that horizontal distance all on board. So you can see all those different values real quick, like through the heads-up scope. When we incorporate the compass, you see it on our 3D models on the diagram on the right side. We get that azimuth, the AZ. So now we get the degree of azimuth in there. Press the fire button, acquire that measurement to the targets, and we're able to measure those values right off the bat, and then also calculate those different values. Which leads into the different models that we have. We have different models that fit maybe your application or your needs. We've got a True Pulse 200 series. What we've got here, we've got two different models, the True Pulse 200 and the 200X. We've got different range accuracies that might fit your application again, or your tolerances. We've got the 200 gets down to 8 inches. Then we've got the 200X, it's 1.5 inches. So again, we've got also different white papers that Steve has written talking about different height measurements and how these values are calculated also. So didn't talk about the communication, but we do have Bluetooth communication built on board. So with the True Pulse 200, we talk to Android and Windows devices, and the 200X, we're also be able to interface with iOS. When we incorporate that azimuth, we get that compass sensor built in. Now we've got the True Pulse 360 series. We've got a True Pulse 360R, the ruggedized waterproof housing, kind of a binocular style look. You can see the accuracies here. The main thing is looking at that azimuth accuracy. We've been able to increase that down to 0.5 degree. So that really comes into play on some of these measurements that we're going to talk about, that span measurement. So really comes into play there on the different accuracies. And so we have two different models of the 360 series, you can see. And again, we've got Bluetooth communication on these two models, Android and Windows that they're able to communicate with. One of the newest models we come out with is called the TruePoint 200H. This is where we've got this, we just released this over this last year. What we do is we call it the hybrid laser. We've taken that pulse technology I've talked about, where we don't need a reflector and a reflectorless technology, and we've combined it with a phase technology, which is like kind of like your laser pointer. So you can actually see the laser pointer. We've combined those two different measurement technologies into one device. With that, we were able to increase the accuracy. Our range is a little less than the True Pulse line, as you can see, but the accuracy is really increased, especially on that short range. So some of those separation values you were talking about, Joe, about the 12 inches or 40 inches, this is a really good device that you can use that and take those measurements, and you can see the range accuracy values there. This does also have Bluetooth communication. We've upgraded the Bluetooth module in this device, so we've got the BLE, so communicates with all different type of devices real seamlessly. And the last laser we've got kind of combination. Again, like if you're using a compass module, and it might be in construction zones where a compass might be infected. It might be interfered by magnetic interferences. We've got what we call a true angle. So we're still able to measure that horizontal angle with this device here, in combination with the lasers. And so you can see the accuracies we've got here, the different angle accuracies we've got when you staff mount it. It's kind of more of the typical style of maybe like a total station, but a lot smaller, easier to use and lightweight, and much less expensive. So you've got all different types of models to take all these different measurements, distance measurements and angle measurements, but we also have some routines built on board that's to help calculate or to help measure some of those values that are needed. And Steve's going to walk us through a few of these.
Right. As Derrick mentioned, he covered all the raw sensors that are on board and a couple of the calculations for HD and VD, but we also have a couple of other measurement routines that lead you through a sequence of shots and give you a real helpful result. Joe mentioned earlier the height on the poles, height of attachment, HOA, are very important when doing a pole audit. That's often the crux of it. So our 3-point height routine that we have is just perfectly set up for that. And mostly because the foam poles are predominantly nice and vertical, straight up and down, flat surface there. So the first shot you take is a horizontal distance. So if the base of the pole is obscured or even, other parts of it, you just find a clear spot you can see to the pole and you shoot it there. It'll measure both the distance and inclination and calculate that HD for you. So anywhere on the pole is good for that shot. The second shot is to the base of the pole. Now this is just an inclination shot, just a tilt shot. You don't need any kind of return for the distance. So if the base is obscured, you just visually estimate where that is and pull the trigger. Now you just take your top angle. In this example, we're going all the way up to the cross arm there. This will complete the solution then, and a height value will be calculated. So, this is your first measurement you make on your form, let's say, boom, you got that height value. If you don't have any kind of connectivity or other technology, you can just start writing these values down. Derrick mentioned the Bluetooth communication. We can get the data out electronically, wirelessly as well. So another nice thing about this routine, then, you're going to have multiple shots here that you want to catalog on that pole. So instead of having to shoot the base and the distance and base angle again, you just do one quick key press on the laser, any of the lasers, and it will back up to that top angle shot. So now you just move down the pole, say to the bottom of the transformer here, take your shot, you've got another height value calculated. Back up one, come down to that communication wire, boom, you got another height calculated and out to your data collector. So a great way to catalog those HOAs on the foam poles. So let's say you get into a scenario where you need the pole isn't upright. It's leaning. Maybe they've had a storm come through and it's leaning real bad. You still need to get some height measurements. Maybe you've got another leaning type object. We have another routine on the laser called missing line, which we're going to see does quite a few of these other measurements now that they typically need to make. But you can also get a good height value on a leaning object with it. In this scenario, you have to get distance and angle to both the base and the top, both of your shots you're taking. So, if the base of the pole happens to be obscured, you could always, put a marker 4 feet up on the pole and, or some other object there, shoot that and just add it in. But you take shot 1 to the base there, distance and angle, and then you take shot 2 to the top. And again, distance and angle. And then it will give you a solution of all the information in between there, and you just scroll around to the vertical distance value, which will be in that vertical space, and that would be your height essentially for that type of leaning object. So that's another way you can get that value. So yeah, and then you can likewise just back up if you need to take another height with that same base shot, you can just repeat shot 2 if you need to. Take other measurements on that leaning object. So a couple of different ways to get span then. We talked about that as another needed measurement. One way, if you've got to go up to the pole, say, and read a tag number or maybe even put a tag on it, you could just put the laser right next to the pole and shoot to the other pole that you need to measure to. Just get a direct readout of span right there, usually the horizontal distance. So that's one way to do it. If you can't occupy the pole or don't need to, you want to stay in a safe location or a efficient location, you can use the missing line routine again. Now this measurement is going to require the compass or the angle. So as long as you have the 360 model or the true angle, you can make these types of measurements. So you just take shot 1 to one pole, shot 2 to the other, and you can get your span there. Here we're going down the road. So again, the HD is typically the span value they're after here. They can even look at the vertical distance value in this result and get an idea of the change in elevation between the two poles too. If they shoot the same spot on the pole, they can see that information as well. So that's the 3D span. You use the same missing line routine now for clearance. And these measurements can be made with the 200 model if you stay nice and vertical between your shot 1 and shot 2. That's going to be critical if you're looking at any horizontal distance type measurements. If you're just looking for vertical values, VD values, then you really don't have to worry about staying so vertical. You just want to make sure you hit the proper points. So we're doing the clearance over the roadway here. And the first shot is going to be to the wire. You pick out that point in the wire that's either the lowest point, or sometimes they do it right over the center line of the roadway or whatever, right, Joe? It may not necessarily be the low point, but just wherever that traffic is going to move through and everything. And so you pick that spot on the wire, and then you come down to the road surface itself with shot 2. So here you want to try to hit that spot right underneath, but if the road's fairly flat and level right there, anywhere in the vicinity will give you, again, that good vertical distance value. Scroll around till you see the VD value, and that'll be your wire clearance there over the roadway.
Right, and we got that true scan, right, Steve, where, so if you took shot 1 and you took it to the first part of that conductor or wire over the road, and you note that horizontal distance, say it's 45 feet, and then when you go down to your shot 2, you can press and hold the fire button. It will continuously fire the laser and update that horizontal distance, and you can kind of pan back and forth and try to get as close as you can to that 45 feet again, and then you're now you got 2 horizontal distances that are the same for shot 1, shot 2.
Right, that's a great tip, and it takes a little practice and technique to get it right. And when you release that trigger with your good distance, you want to stay nice and steady there. But that's a great way to try to find those 2 points in space. That one that's kind of unclear on the roadway. Yeah. So the SAG routine again uses that missing line function that we have on there, looking for the vertical distance value. So typically you shoot an attachment point first, and then you find the low point in the cable here. And most of the time it's mid-span. If the ground's flat, if the ground's uneven, then that low point will move. But that resulting vertical distance value, again, is what you're after for SAG. And again, the 200 model can even be used here. Even though you're kind of swinging in a horizontal motion, as long as the value you're looking at is vertical distance, that's still going to be good in this case. It's all from the frame of reference of the laser, so it works.
Well, yeah. Hey, thanks a lot, Steve. Appreciate you walking us through different ways of using the lasers, of capturing just the raw distances and values, but all the different routines we can do to measure all those different values that are needed for a pole audit. So let's go lead into another poll question. We'll give this a try again. To using your take a picture of the QR code, and if you have taken some measurements, or how are you actually using, or what are you using in the field? So I'll give this a here about 30 seconds or so, see if people take a picture, and then I'll jump over and see if we got any results from this. Appreciate all your guys' time today and the feedback we're getting. So we go to here, and then there we got poll questions, and then do I need to navigate that, or
go back to my surveys.
You bet.
And then go to LTI number 2.
Number 2.
And analyze. Yep.
Learning on the fly. All right. Well, great. Appreciate everybody giving us some feedback. You can see here, we've got all sorts of people eyeballing and using everything out there. So again, you can see people are using all different types of equipment they can to take these type of measurements. So appreciate everybody's feedback there on that poll question. And so one thing, you know, we talked about all those different measurement routines are taken and everything you do is one of the biggest thing is like, what do I do with all these values? What do I, you know, I can measure a height value. I can see it on the in the laser itself, or what do I download it to besides handwriting? So documentation is very important, as we've talked about, as Joe's talked about, is just all the different, you've got to document. So what you're doing out there. So we've got just to talk about a couple apps that we interface with. One is we design our own apps to work with our laser rangefinders. This one here is called LaserSoft Measure. It's a free app that interfaces with with the lasers that have communication. And you see here on the right hand side, it captures that raw data values, that horizontal distances and everything. So right there, you're able to see the values being captured. Or if you're doing a height measurement, you can see that value populate, or a missing line value. And you can make some generic notes, get some documentation. One thing, we use the device's camera to take a picture too. There are some different adapters you can take your phone and attach right to the back of the laser rangefinder, looking through the scope. So you see those pictures there, it's actually looking through the heads-up scope, and you can do these measurements. So if somebody asks, like, did you really take a measurement to the top of that pole? Yep, I have a picture of it. Here's the height value that I calculated. Here's the notes, and here's even the location of that. So it's a good, quick and easy way to do that. But you know, there's other people want a little bit more documentation, or they want to have a lot more information on one file. This app called GeoJot Plus kind of allows you to do that. Interfaces with all our different lasers. You can build up different files. Like I need to do multiple attachments. I got to get more information on that attachment, what type it is, and company, and not just the height. So you're able to do that, and you build these files within the GeoJot app here, and you can capture that. And our laser information goes right into the app. You know, capture that height values or the span values that Steve talked about, that we output those different values to. So this takes a step further. And also, you can geo-reference your location and also the pole location. So so if you need to know, you know, safety factors come into play here. You don't want to walk up to every pole and calculate, or stand there with your device and capture that pole location. What we can do is we can stand in a safe environment, side of the road, and then take a measurement over to that pole, and that app actually calculates that remote position. We call this laser offset mapping. So using the device's GPS, or maybe even a higher end GPS device, you occupy your current location, and with the laser rangefinder that gives us our distance, tilt, and our azimuth direction, you take a measurement over to that object, and the app is going to calculate that remote coordinate. And so that can happen within GeoJot. And there's some other apps and solutions that we interface with.
Hey, Derrick.
Trimble guy. Yeah, Jay.
Derrick, about the GeoJot software, if you go back one slide, if you could. The benefits of it too are the reporting, whether it's your standard PDF, CSV files, or bringing it out to Esri shape or geodatabase format. So it has some benefits other than just building a form and being able to shoot all those offsets or attachment, height of attachments within the actual form building itself. So the reporting is very key.
Yeah, that's correct. Yeah, so glad you caught that, Jay. Yeah.
It's all right.
It's good taking into different databases. That's what's more key about this. It's more of a full-blown app than our free measure app. So you're able to do a lot more with this GeoJot. And so that kind of takes the next thing. You know, you guys are a Trimble reseller, and we interface a lot with all different Trimble devices and apps. And so I'm going to lead that into the different ones that we interface with.
Yeah, so there is a Trimble software called Trimble TerraFlex that is a cloud-based annual subscription fee cost associated with that. Pretty much works with almost all of our receivers that we have now. to go out there and collect data. And the biggest thing that we want to focus on is we want those people to be safe, because you can't always get to a location of where you can't always get to the pole. Like there's been times where in the last project I'd done, I probably touched 80,000 poles and was up to them. And a lot of times I was put into situations where I was not safe. There's been times I've been eye level with power lines because I was on the side of a hill trying to get to the next pole. So, with this laser offsets, we could really keep everybody safe. And in TerraFlex, we can do those offsets and capture the GNSS location of that pole and keep your guys safe out in the field. Now, it's not going to include the workflows of missing line or height attachments, but you could always measure that and build that into your form, and then copy that over to into your attribute field when you're collecting that information, and then it's back in the office and you have that readily available.
Yeah, perfect. Hey, thanks, Joe. Yeah, our lasers interface with the Trimble hardware and the TerraFlex. There's a couple different workflows you can see here with our lasers being used along with those solutions. And just recapping everything we talked about is Joe and Steve gave us a really good summary about why people perform audits, what's needed between violations and from just regulations and safety factors and what's on it. So utility pole companies or whoever the pole owners can charge rent. Also, just the different laser measurement solutions we went through, all these different values. And one thing is kind of measure more, move less, and the safety factor, safety kind of thing. As you can see, a lot of different things. A lot of people are out there might not be paying attention. They really don't pay attention on the side of the road as much. Or when they're driving, they don't pay attention who's there. They're going their own place. So one of the things is you can take measurements from all different areas, from the field, from sidewalks, etc. And also about that documentation of capturing the data, capturing pictures, and what is actually on the pole. You've got that documentation to take back to different companies and show them what's there. We have some YouTube videos about different training ones. Our Laser Tech video here, or Laser Tech YouTube channel. You can check it out. We've got some different videos of using our equipment with the GeoJot, just standalone, maybe taking it into mobile Excel. Different things that you can capture all those measurements, or all those different values we discussed. But we have a lot of training videos out there about how our lasers interface with everything. And one of the best things working with partners like Seiler is they're here to support us, support you, and they know our equipment. They know it very well. They are the experts in the field. So if you're looking for any demonstrations or want to learn more about it, these are the guys that contact. Here's all their information that you reach out to them. If you want to reach out directly to us, you're welcome to do that too. But we really want to appreciate Seiler today hosting this webinar and letting us speak on this solution. I think it's a really good solution, and I think we have a lot of different hardware that goes along to help solve some of those problems that when people need to take those measurements on a pole. So I'm going to kind of wrap it up here. I don't know if our team, if we've seen any questions or anything like that come through. I'll wait here for a second if any questions pop up. But if you have questions later on, please reach out to the Seiler team. You can reach out to us. We can answer those questions. But again, I really want to appreciate Joe and Jay getting on here today, and Steve. You guys are the experts in this field. Appreciate you guys' time, and thanks everybody. We'll go ahead and end this. We've got this webinar recorded, so we'll pass it on to some colleagues. Appreciate everybody's time, and be safe. Thanks everybody.
Yep, thank you.
Bye-bye.
Thanks.
Bye.
Thanks, Derrick.